What is the role of the capacitor in starting and running a ceiling fan? What is the role of the capacitor? Ceiling fans rely on a reliable power source and a highly efficient motor to provide air circulation. While the motor does the heavy lifting, the humble capacitor is arguably the most crucial component that allows the fan to start rotating and ensures it maintains a smooth, efficient speed. Without it, the fan would merely hum or wobble without turning. The motor type: single-phase AC. Domestic ceiling fans use a single-phase AC induction motor. The electricity supplied to homes is single-phase, meaning the alternating current, AC, cycles back and forth along one path. A single-phase supply generates a magnetic field that only changes in magnitude, strength, not in its orientation, direction of rotation. This pulsating, non-rotating field means the motor has no starting torque, it needs a separate mechanism to kickstart the rotation. The role of the capacitor: creating a rotating field. The capacitor's primary job is to solve the starting torque problem by effectively turning the single-phase supply into a two-phase supply within the motor. Phase shift. The capacitor is connected in series with a dedicated set of starting windings inside the fan motor, storing and releasing energy. As the current flows, the capacitor stores electrical energy and then discharges it. This process causes the current flowing through the starting windings to become out of phase with the current flowing through the main, or running, windings. The phase difference is typically about 90 degrees. Generating torque. This difference in current timing creates a true rotating magnetic field inside the motor, rather than a pulsating one. This rotating field is what applies the necessary initial torque to the fan blades, getting the motor spinning. The fan starts. Run capacitor function. Once the fan is spinning, the capacitor often remains in the circuit and is then referred to as the run capacitor. Continuous operation. Unlike some large motors that use a temporary start capacitor, which is disconnected after rotation begins, ceiling fans use a single start and run capacitor. This keeps the phase shift active during operation. Efficiency and smoothness. The run capacitor maintains the elliptical or near-circular rotating magnetic field, ensuring the fan runs smoothly, efficiently, and at a high speed. If the fan runs slowly, or starts only with a push, the capacitor is the most likely culprit, as its ability to hold a charge has degraded. Capacitor rating and replacement. Capacitors are rated in microfarads. A typical ceiling fan capacitor ranges from 2.5 to 3.5 microfarad. Degradation. Over years of use, the internal dielectric material of the capacitor breaks down, reducing its capacitance value. This weakened capacitance results in a less effective phase shift, leading to the fan running slowly or failing to start. Safety and maintenance. Replacing a faulty capacitor with one of the exact same voltage and capacitance rating is a common and usually simple repair that restores the fan's speed and function. Always disconnect the power before inspecting or replacing a capacitor, as it can store a charge even when the fan is off. Summary. The capacitor is the ignition key for the ceiling fan. By introducing a phase difference in the current between the motor windings, it transforms the single-phase electricity into a rotating magnetic field, generating the starting torque required to get the blades moving, and ensuring the fan operates efficiently at its intended speed.